All right, welcome to the Lab 12 Thunderstorms and Tornadoes for weather. And I did some highlighting of some information, and this one I'm going to try to walk through pretty closely and carefully, so it might become a very long video. So first off, I wanted you to point out just some of the little paragraphs. This is one of those where reading the paragraph really helps you understand the question at hand that they're asking, so do take some time. But one of the key stuff is that in the United States, thunderstorms most frequently occur when maritime tropical air is forced aloft through orographic lifting, frontal lifting, and intense face heating, convergence, and surface airflow. So that little part that I highlighted in the paragraph, that's the 4 different ways that you can build clouds, right? That's what they're talking about. So orographic is geography. Frontal lifting is on the front. Think of the cold front and that bubbling shape. If I take it in profile, that we get the really tall cumulonimbus cloud. So that's frontal lifting. Intense surface heating, that's going to be the act of just normal lifting. So this hot air rises, right? And then convergence on surface airflow. This is something along the lines of when I have something like a frontal lifting and I have a downdraft. That downdraft has to push the air that is on the ground up or out of the way. And so that's surface airflow. So it's air along the surface getting pushed around. And so there's 4 ways that you can build a cloud, and they're listed right there. You're going to need that for another set of questions. So question 1, what is the major source of maritime tropical air affecting the United States? How does the proximity to this source influence spatial patterns in thunderstorms? So once again, the key word is maritime tropical. We learned what that is. That's little m, so a lowercase m, capital T, right? And what you're doing is you're looking for that tropical air mass that would be around 30 degrees north latitude or less, that would be warm and moist and cause a whole lot of thunderstorms. So for this, you might need to grab the map or a globe, but you're basically looking to find where the maritime tropical air mass is coming from. And as we can see, the frequency of thunderstorms is right down here in our image, and this is my MT air mass. And you're just writing in the name of that geographical location on the question 1. So I'll leave you to look that up. It's pretty straightforward, but you gotta look it up. So what process over the Florida Peninsula, this is question 2, forces maritime tropical air to rise and lead to high frequencies of central Florida thunderstorms? What process makes this air rise? This is another one that goes into stuff that we previously learned, and this is asking you about air cells. Which air cell is having its active high energy at about 30 degrees north in the latitude? So which air belt, if this is the Earth's surface, right? I've got my little Earth surface. This is my high belt. This is my low at the intertropical convergence zone, ITCZ. Which one's happening at the high? We know this is the subtropic high. And then we get right in here at the subtropic high. Well, air streams along the surface and slides towards the low pressure center at the polar front, right? At my low pressure center around 60, 50 degrees north latitude, depending on time of year. What's going on right here? What is this cell bubble on the surface of the Earth? So I'm asking you to remember something, and that's what's occurring here. That's the question. And then question 3, what geographic feature might contribute to the high frequency of thunderstorms in central Colorado and northeast New Mexico? So this is keyword geographic feature. We're talking about what type of these sorts of cloud formations are occurring. And I kind of highlighted it over on the spatial patterns of thunderstorms. And so this one you're going to be looking for that orographic feature that's going on prior to Colorado and New Mexico. What's happening West Coast style. So a lot of this is grab something and look it up, or remember what we've learned, right? So question 1, figure out what that landmass is. Question 2, if you've forgotten the names of the 3 cell bodies, what's that middle cell body with the westerly winds? that causes air to stream? And then question 3, what is the geographic feature that is right here that causes the desert sliding here that dries it out, that allows this maritime tropical air to mingle with? What is that geographic feature? So that's your first 3 questions. Now let's look at question 4, which is some really easy math. If you see a lightning bolt in the distance and 15 seconds elapse before you hear the corresponding thunderstorm, how far away was the lightning bolt? Well, down in this paragraph about lightning down here, they give you some information, and they say that sound will travel approximately 340 meters per second. This is equivalent to about 1/5 of a mile per second. So for every second that goes by, you go 1/5 of a mile per second. So looking at this question, if I go 15 seconds, I'm going to go 340 meters every 1 second, and times that by 15 seconds. I'm running out of space on my page. 15 seconds. And I will get my answer for this, right? So let's clean that up. Maybe I can write it smaller. Hard to write with the finger. 340 meters per second times 15 seconds. And I'll get my answer for this part, the first one. For the second one, I go 1/5 of a mile. So if I go 15 seconds times my 1/5 of a mile, right, I'll get myself 3 miles. So the first one you do math, and the other one was easy math, right? And we can just do that quickly. So there you go for your next set of questions. And that brings us to our paragraph. It talks about air mass thunderstorms rise when air becomes unstable, and that's a key thing. And we want to think of this as being a mingling or mixing of air masses, but specifically the maritime tropical air mass coming from the Gulf of Mexico, right, in the United States. The other key part of the paragraph talks about what's going on in these 3 stages of building a thunderstorm. Stage 1 is the cumulus stage, and it's all updraft, so you think updraft. Stage 2 is the mature stage. In the mature stage, you have a balance between the updraft and the downdraft. And then stage 3 is the dissipating stage, and this is all downdraft at this point. So I'm running out of space again. But that's my key parts to this paragraph. So looking at the next set of questions for question 5, and I'm sorry, my image did not copy very well. So I'm going to read you question 5, but it's not being shown very well. But once again, I highlighted key things. So recall that updrafts within a thunderstorm result in moist adiabatic cooling. How is energy released within the cloud in the process, and how might this foster more upwards motion within the cloud? So we are in the moist adiabatic process. That's a key word, it's moist adiabatic process. And since it's moist, it means that I'm changing phase, right? So I've met the lifting condensation level. So question 5, to answer it, you've met the lifting condensation level, so what process is occurring is the changing of phase. Latent heat is occurring. This is one of those when I said latent heat is the answer. Latent heat is the answer. Latent heat is happening. I'm flipping from the gas form to either a liquid or a solid, and therefore I'm slowing the cooling process, making it continue to rise because it's not cooling off as quickly. So that would be my answer. Latent heat, because it's slowing the cooling off process. Question 6. Air drawn into a thunderstorm forms outside its usual cooler than air within the cumulus cloud. Explain what effect this should have on vertical motion. Well, if the air being drawn in is cooler, that means that the cloud itself is warmer. And if the air in the adiabatic process is warmer then the cloud's going to rise, right? So this is my natural vertical motion. So that would be my answer there, right? It's warmer then, and therefore I will create an updraft. So keyword here is updraft. and up here is latent heat. Alright, so I'm going to stop the video here and start with a video 2, that way I can put this up on YouTube.